Geo means earth, and thermal means heat. So geothermal energy is just the heat of the earth, which we use to make electricity, or heat and sometimes even cool buildings. There are three main types. The first is by far the rarest, but the most powerful. At geologic plate boundaries like Japan or California, or geologic hotspots like Iceland, the heat of the Earth's interior comes very near the surface, and it superheats the groundwater. We can drill wells to tap into this hot water and steam, which can then be circulated into people's homes and through simple radiators. Whole cities can be heated this way. Or it can be used to drive steam turbines, similar to those in other kinds of power plants, to make electricity. This is an amazing energy source, but since hot spots and plate boundaries are not widespread, it's not widely available. There's a second way to get hot water from the earth. Vertical wells are drilled and hydraulically fractured, much like an oil and gas well. Water is pumped in here, where it's heated and produced from a well here. Some think this technology has the potential to generate significant electricity worldwide. But today it's experimental and therefore expensive for the amount of energy that it returns. The last kind of geothermal can be done almost anywhere. Just below the surface, the Earth stays a constant temperature. In the US, that's between 60 and 70 degrees. If we bury a long closed loop of pipe, either in trenches or vertically to as little as 200 feet, and then circulate water through it, it takes on the temperature of the Earth. We then pump it into a building and blow air across it, like a regular heating or AC system. This keeps the building at a constant temperature, whether it's hotter or colder outside. These systems are twice as expensive to install as conventional heating and cooling, but they're cheaper to operate, longer lasting, and produce fewer emissions. That means this most widely available form of geothermal energy may be the most adopted of all three.